Hi guys, so in this mind wrap we're just going to go over the different ways we measure variability, and we'll talk about range and interquartile ranges and how to figure those out. So let's just talk about what variability is. So this just refers to how spread out our data set is. And when we talk about spread out, we usually refer to a lot of that with standard deviation, which we'll talk about how to calculate later on in a different video. But what that does is it tells us that the smaller the variation or the variability, the more compact the data is around the mean. And then the larger the variability, or the larger the range, or the interquartile range, or the standard deviation, whichever variability measure we're using, the larger that number is, the more spread out the data is compared to the mean. So when we talk about variability, we are always referring back to the mean, or the average data set value in the data set, and then how far away from that is the rest of our data. So this just, again, gives us a way to describe how much variation is in the data. Again, a large standard deviation or a larger range means our data is much more spread out, and a smaller standard deviation or a smaller range means that our data is much more compacted around the mean. So in addition to this, it also allows researchers ways to compare data sets. Right now we would be looking at data sets that are on the same scale level. But later on in Chapter 5, we're going to talk about the standard scores and z-scores, and that actually allows us to compare data sets that are not on the same score level. So that's a really nice way, but it allows us to look at two different data sets and talk about how much variation is in each one. And then we have four main ways that we talk about variability in a data set. We have range, which is just your high value minus your low value. And then the interquartile range, which we'll talk about here in a little bit, variance, and then standard deviation, we'll talk about in the next video. So let's just talk about range. So this is the amount of distance between your smallest value and your largest value. There are actually three ways to calculate this. It seems kind of weird that we'd have three ways, but we do. The first is that we do the maximum minus the minimum. So basically your highest value minus your lowest value. We have an alternate for continuous. This would be something we would use like on a frequency distribution. We would use the upper real limit maximum and the minus the lower real limit maximum. Remember, we talked about those upper real limits and lower real limits when we were in Chapter 1, and that's where we found that halfway between the distances of two scores. So that would be one way to do it. The other one for discrete is you do your maximum minus your minimum plus 1. Okay, so you need to pay attention as to which method it's wanting you to use. Probably the most common is just the very first one, where we do the high value minus the low value. Now the problem with range is that it is very susceptible to what we call outliers. We've talked about outliers before. We talked about how if I have a data set that's kind of out there by itself, it really affects my mean. Well, it also really affects my range. So one way we get around this is we start talking about these things called quartiles. Okay, so we have three quartile values we find. We have the 25th percentile, which is Q1. We have the 50th percentile, which we call Q2, and the 75th percentile, which is Q3. Just as a side note, know that the 50th percent quartile, the Q2, is actually our median. So when we're talking about quartiles, we're really talking about medians. So this divides our data set up into 4 equal parts, and they all correspond with 25% of the data. Again, note that the Q2 is also our median. So to find the quartiles, what we're going to do is we place our numbers in order because we are finding a median. And remember, anytime we talk about median, it's always going to be numbers in order. So the second thing we're going to do is we're going to find the median of the data set. That's our Q2. And then we find the median of the lower half, and then we find the median of the upper half of our data. So the lower half of our data would be our Q1, the upper half of our data would be our Q3. So to kind of give you an example of this, we're going to do two examples, one with odd numbers and one with even numbers, and see how that works out. So our first example, we have the odd number data set here, 83, 93, 79, so on and so forth. We've got all those nice numbers. Again, the very first thing we're going to do is we are going to put those numbers in numerical order. So starting with 29 being our lowest, 99 being our highest. Since there are 11 data sets, there we go. The middle of our data is halfway, which would be our sixth data point, which would be the 63. Now, because it's an odd number and we're using the 63, when we find our Q1 and our Q3, we actually will not use the number 63. We'll use 29 through 47, which is also an odd value. So our Q1 would be the middle value here, 44. And then on the other side, we would go from 74 to 99. Again, that's an odd number of data sets. So 83 is going to be our center of those 5 numbers. So that would be our Q3. So we have our Q1, which is 44. That's 25%. Our Q2, which is 63. Our median, which is 50% of the data. And then our Q3, which is our 83, and that's 75% of our data. And remember, it's that 25% of your data lies below Q1, 50% of your data lies below Q2, and 83% of your data lies below, 75% of your data lies below Q3, in this case 83. There we go. So let's look at it for an even number of data sets. So this one has 10 data values here. Again, whether it's even or odd doesn't matter. We first start off by putting them in order. So we're going from 1 to 10. Since there are 10 pieces of data, what we're going to have to do is take the middle 2. I'm sorry, there's only 8 pieces of data. My bad. So we're going to take the center 2, which is 5 and 6. Remember, we're going to add 5 plus 6 and divide it by 2. So we got 5.5 is going to be our Q2, our median. Now, unlike when we did the odds where we left out the median, 5.5 is actually not a value on our data set. So when we find Q1, we're going to take half of the data. So we're actually going to look from 1 to 5. So we're going to use all of those numbers, including the 5 that was part of how we calculated our Q2. Again, 1 through 5, that's only 4 data sets or 4 numbers. So we're going to have to do the same thing we just did. We're going to take that 3 and 4 in the center, add them together, and divide by 2. And we get that Q1 is going to be 3.5. And then lastly, we're going to do the same thing over here for our Q3. Again, we're going to go from 6 to 10. We're going to use all of those numbers. It's an even set. So again, we're going to have to add that 8 plus 10 and divide it by 2 and find out that our Q3 is 9. So in this particular one, when we're doing an even number of data sets, because the Q2 is actually not a value in our data set, when we break it apart for our Q1 and our Q3, we use the entire data set and you break it completely in half. So 1 through 5 went into the Q1 data set, and 6 through 10 went into your Q3 data set. Now, the other really cool thing that you can do with this is you can actually do a box and whisker plot, and we use our Q1, Q2, and Q3 to create our box and whisker, as well as our low value and our high value. So I'm using the exact same data set we just talked about. So we already know all of those values. Our low value is going to be 1. Our high value is going to be 10. So we get the low at 1, our Q1 at 3.5, our Q2 at 5.5, Q3 at 9, and our high at 10. So I'm going to got a number line here. And what we're going to do is we're going to create a box that goes from our Q1 to our Q3. So just a rectangular box that goes from 3.5 to 9 on our number line. And when you're doing this with the decimals, it just has to be in about the right spot if I'm drawing this by hand. Obviously, it's a little harder to draw these by hand when we're on the computer and stuff like that. The next thing we're going to do is we're going to draw a straight line in our box right where our Q2, our median, is. So there's our 5.5, our median. So basically we're just kind of splitting that box to where the half point is. And then the last thing we're going to do, and these are where your whiskers come in, because the box and whiskers. So your whiskers come in from your low value and your high value. So you're going to put a dot at your low value 1 and then just draw a line straight out for that. And you're going to do the same thing for your high value. You're going to put a dot at 10 and draw a line to that dot. And there's your box and whiskers. And it's your, we call this the 5-point summary. You get your low, You get your Q1, your Q2, your Q3, and your high value. So you get those 5 data points, and it just lets you kind of see where the vast majority of your data lies. So we know that the vast majority of it is between 3.5 and 9. It lets you see where the middle of your data is. So we see that 5.5, and then it also gives you the low and the high of the data. Okay, so the last thing we're going to talk about is interquartile range. So again, remember this is just another version of range. We call it IQR. It's the distance between your first and your third quartile. So it's Q3 minus Q1. So what we're going to do, again, I'm going to use that same example we just did a second ago to do our box and whisker plot. We know that our Q1 was 3.5. We know our Q3 was 9. So our interquartile range would be 9 minus 3.5, which is 5.5. And I want you to think about something, because if I did the range, just the normal range on this problem, it would be 10 minus 1. Right? The high value of 10, the low value of 1. So 10 minus 1 would give me a range of 9. You notice that's a lot larger than my interquartile range. Again, we like to use the interquartile range when we have extreme values in our data, because it does narrow down exactly where the vast majority of your data lives. So a while back we had this graph, I think we found the mean on it in one of our previous videos in the chapter. And we talked about how we did have some extreme values over here with our 90 and 95K for staff members 9 and 10, and how that really threw off our mean, but we were able to use our median to kind of get a better picture of what was going on here. So if we do just this normal range, which would be the maximum value minus the minimum value, we would have 95 minus 12, which would give us a range of $83,000, okay? But again, because of that 95,000 and the 90,000, it's really throwing off the range. So if we use the IQR and we find the Q3 and the Q1, which in this particular case happens to be 15 and 18, and if I subtract those, I get an interquartile range of 3. And I do realize that those are backwards. It really should be 18 minus 15, not the other way around. I apologize for that. Your IQR, your range will always be positive. So if you do make a mistake like this where you reverse the numbers, that's okay. Just make it a positive number, because they are always positive. But we get a much more understanding of the range of this data, that we're really only talking about $3,000, not $83,000, because the vast majority of people are fitting between 18,000 and 15,000. Okay. I hope that this helped you with interquartile range. If you have any questions, just let me know.